In this section, we want to solve by completing the square. So remember, completing the square, we want to get the c value out of the way first. And so for number 7, the c value is already out of the way. I've got x squared minus 6x, and I just put a little bit of space in there. Okay, I'm going to pick a c value that gives me a perfect square trinomial. And the c value that's going to give me a perfect square trinomial, to find that, I just take the b value, I divide it by 2, and then I square it. So the b value this time is a negative 6. I'm going to divide that by 2, and then I'm going to square that whole thing. Okay? So negative 6 divided by 2 is a negative 3. Negative 3 squared is a positive 9. So to complete the square, I have to add a 9 right here. And what that does is it creates a perfect square trinomial. X squared minus 6x plus 9 is a perfect square trinomial. It's going to factor into a binomial squared. Okay? When I'm solving by completing the square, the thing I have to remember here is that I just added a 9 to this side of the equation. So I have to add a 9 to this side of the equation as well. So I'm going to add 9 over here too. And now I factor this thing. And a couple things to note here. I can build a bridge and factor it this way. Two numbers that multiply to a positive 9 but add to a negative 6 are going to be a negative 3 and a negative 3. So it's x minus 3 squared. But keep in mind this piece of the binomial right here. It's always the b value divided by 2. It's the thing I had right here inside parentheses when I was doing the process of completing the square. And that'll always be the case. So that factors into an x minus 3 squared. This equals a 12. So now I have the situation that I had earlier when I was finding the x-intercepts from vertex form. But I have something squared equals a value. To undo squaring something, I'm going to take the square root of each side. So that gives me an x minus 3 equals. Again, whenever I take the square root of each side, I have to do plus or minus. So that's plus or minus the square root of 12. Well, now I have to simplify the square root. And the square root of 12, I'm looking for perfect squares that divide evenly into 12. It's going to be a 4 times 3. So now the square root of 4 is 2. So it goes to the outside. It's a changed number on the outside. The 3 is still trapped. Okay, so it leaves me with this situation. And now the last thing I have to do to finish solving for x is I have to add this 3 to each side. Okay? And when I do that, this is how I'm going to write my final answer. I'm going to say x equals the positive 3 plus or minus the 2 root 3. Okay? And that's it. In number 8, I'm going to solve this one by completing the square also. But in number 8, I've got x squared plus 4x plus 6 equals 0. And again, the first thing I want to do is I want to create space. I want to get rid of that constant term. So I'm going to subtract the 6 from each side. So I've got x squared plus 4x with a little bit of space equals a negative 6. Okay? So I move that guy over. Now I complete the square. I do the same thing I did earlier. Take this off to the side. I take the b value, which is 4. I divide it by 2. And then I square the whole thing. So 4 divided by 2 is a 2. And then I square it, which gives me a 4. So now I know to create a perfect square trinomial, I have to add a 4 right here. But whatever I do to one side of the equation, I also have to do to the other side of the equation. So I add 4 to the other side as well. And what that's going to give me, it's going to give me an x plus 2 squared. Again, I'm just factoring that. And if you're unsure about that step, just build a bridge. Two numbers that multiply to a 4, but add to a positive 4. It's a positive 2 and a positive 2. So it's x plus 2 squared. Over here, I'm left with a negative 2. And now, once again, I can solve using the square root. So I take the square root of each side. I'm going to bring that up here. Remember that when I take the square root here, I get the x plus 2. Over here, since I took the square root, I have to do plus or minus the square root of a negative 2. And keep in mind, when we have square roots of a negative, this is where we get imaginary numbers. This is the same thing as 2 times a negative 1. And I know how to take the square root of a negative 1. The square root of a negative 1 is an I. All right, it gives me the imaginary number I. So I get plus or minus I root 2. Okay, the square root of a negative 1 is an I, goes to the outside. It's a changed value on the outside. The 2 is still trapped. And now I subtract the 2 from each side. So x equals a negative 2 plus or minus I root 2. All right, and this is a case where we get to complex solutions because they have imaginary numbers in them.